One of our most fundamental talents as human beings is the ability to take data, process it, and then make a decision or judgment based on that data. Computers unfortunately don't have this natural ability. We actually have to tell the computer how to make a decision on things and what data by asking questions. And we do this with a combination of the if statement and various operators. There are four basic operators. There's the arithmetic operator, there's the relationship operator, there's Boolean operators, and then there's bitwise operators. However, in this tutorial I'll only be covering the first three. The first set of operators, the arithmetic operators, are simply mathematical statements. You have four primary symbols: plus, minus, multiplication and division. So obviously we know what these mean. 2 plus 2 is 4, 2 minus 2 is 0, 2 times 2 is 4, and 2 divided by 2 is 1. Relational operators come in five symbols. We have equals, we have greater than, we have less than, we have equal to greater than, and we have less than and equal to. As the name suggests, they basically work out the relationship of two pieces of data. The next set of operators are Boolean operators. The three main symbols for these are and, not, and or. Rather than going into detail about them right now, I suggest you wait until the tutorial section and I'll explain these in greater detail. In order to use the operators we've just discussed, we basically have to start by learning how to use the if statement. And the if statement is basically asking a question. If this is true, then do this. If it isn't true, then do something else. So the basic question we're going to assign is A and B the same. So we're going to type in A as integer and B as integer, and we're going to assign these two integers to whole numbers. So A is going to equal 1 and B is going to equal 1. Now, by our own logical process, we can happily look at A and B and say they are the same, they hold the same data, but the computer won't know this unless you actually ask it the question. So we're going to type in if A equals B. So I've used a relationship operator here, basically comparing the data of A to the data of B, and it's going to come up with a response, yes, A does equal B. So we need some kind of response. So then you type in then, and while it doesn't show up as blue, it is actually a command, and we're going to type in print A equals B. So when it works out that A does equal B, then it will print A equals B on the screen. So we'll quickly test that and you'll see it in action. And as you can see, it's compared the two data, it's decided the statement is true, so it's printed that to the screen. So we'll close this now. Now if we change B to equal 0, then it should work out that A doesn't equal B and then do nothing at all because there's no programmed response for it. So as you can see, the program's running, but it hasn't come up with anything, it hasn't been given any choices, so we simply got a black screen. But this doesn't have to be the case. We can offer the program an alternative if the first isn't true. And we do this by adding yet another command, which is called else. And this breaks up the command into the question, then the first response, and if the first response, if A doesn't equal B, then it will default to the second response. So we're going to print it, we're going to print the line, A doesn't equal B. And now when we run the program, it will run the alternative command. So there we go. But having everything squeezed into one line can be a bit of a problem, especially if you want to use multiple commands. So we can restructure the statement so it looks a little bit more logical, a little bit more sensible. So I'm going to delete that now, and we're going to start off with a question, if A equals B. And we're going to mark the end of the question by typing in end if. And this allows us to use as many lines of the program as we need. So now, if we type in print A equals B, then basically it asks a question, it's going to carry out the command, and when it hits end if, that's the end of the question, and it will carry on the program as normal. So we'll run the program now, and of course A is still 1 and B is still 0, so we get no response. So there's still no alternative command typed in. But that's not a problem, we can still use the else statement. So we type in else, and this marks the set of alternative instructions. So we can now type in print A doesn't equal B, run the program, and now it will actually select the alternative. So there you go, A doesn't equal B. It's a good idea to add an indentation before the commands, because it allows you to easily see which commands are occurring in which part of the if statement. If I change this back to 1 and run the program again, it will now select the first option. So there we go, A does equal B. Relationship operators are the most commonly used operators because they allow us to form the second part of the question. For instance, if we just typed in A plus B what? There's no response to compare it to, and we don't know what's going on. So there's no real question there. A equals B, yes, so what? However, if you were to type in A and B equals C, and we add another integer, and we set up C so it equals 2. We'll just change these lines here to a simple yes or no response to the question. So now we know A and B equals 2, therefore it must equal C, so we should have the yes response. So there you go, it's taken two pieces of data and happily compared them to C and come up with a yes response. And if we change C to 3, then we know 1 plus 1 equals 2, so it's not equal to C, and we should get a no response. There we go. You can of course use other mathematical operators or arithmetic operators such as minus. Now 1 minus 1 equals 0, so we're now asking the question, does A minus B equal C? Set that to 0, run the program, and it will come up with yes. So it's effectively taken a sum and worked out the response to that sum. And of course, if we turn C to 1 and run the program again, it will come up with no. If I then decide I want to divide these numbers together and I increase these to 2, we both know 2 divided by 2 is 1, therefore we should get a yes response. There we go. And of course, if we change it to 2 as well, C to 2, we will then get a no response. There we go. And finally, of course, you can use the asterisk, which is actually multiplication. And we all know that 2 times 2 is 4. So A times B equals C should come up with yes. There we go. And now we set it to 2 and it should come up with no. So A times B equals C and the answer is no. So there we go. We've basically been able to create sums here based on existing data, or you could get data from the user and you've been able to make decisions on it. Is this true? Then do this. If it isn't true, then don't do this or do something else. So now we know how the arithmetic operators work. We can have a closer look at the relationship operators. And to do this, we'll reduce the program down to its bare minimum to make it a bit easier to understand. And we'll basically ask the question, is A greater than B? And A is currently equal to 2 and B is currently equal to 2, so they're not greater than each other, so we'll get the no response. So there we go. Now if I change A to 3, so A becomes a bigger number, therefore is bigger than B, we'll come up with a yes response. So there we go, we got yes. We've happily compared 2 pieces of data and worked out which is larger than the other. Another extension of this same theme will be equal to or greater than. Therefore, if I type in 2, then it is equal to B. So A is equal to B, and therefore the equal operator will kick in. So there we go, yes. Again, yes, A and B are equal to each other. Again, if I increase A, then it will be greater than, and we'll still get the same yes response. And the next operator would be less than. So now we're asking the question, is A less than B? A is currently greater than B because it's still set to 3, so we should get the no response. No, A is not less than B. So there we go. And of course, if I reduce A to 1, then it will become less than B, and we can run it. So yes, it is. Again, if I put the equal sign in, it becomes equal to or less than. So if we run the program again, it will still come up with the yes response. But whereas before, if I typed it in so they both match, it wouldn't have come up with yes, it would come up with no. But now that it's equal to or less than, we can, it is yes, so we'll get the yes response. There we go. So now we know how less than works, greater than works, and equals works. You can actually combine the less than and greater than symbols as well. So is A less than or greater than B? So no, it's not. They're both exactly the same value. So it's another way of saying equals, basically. So no, it's not. However, if we change B, then it will become yes, one of the variables is bigger or less than the other one. So there we go. So there are many ways you can use these operators together. Those are the the main ways of doing it. You could put in equals as well, but that would basically mean that everything equals everything else. Therefore, there's no point in typing it in. There's no decision to be made. Okay, I'll delete everything there, and we basically move on to the Boolean operators. So rather than having integers, we're going to set up A and B as Boolean. Now what Boolean basically means is 0 or 1, an on or off state. Anyone who knows what digital is basically knows that it's a combination of ones and zeros, and basically those binary that binary data is used to trigger logic gates, and those come in the form of and, or, and not. So we're going to set up this second one as Boolean, and hopefully you'll see what I mean in a moment. Now we're going to set up a little bit of a program here using the AND gate. Before, if you had A and B equal 1, like this, and you put the plus sign in, then A and B together would actually equal 2. We don't go up that high. We're not using that kind of logic. All we're looking here for is inputs. 0 means off. That means nothing there, not live, not working, out. If it equals 1, then yes, we have a live signal. This can be triggered. And the best way to show this is actually with an if statement. So we're going to type in the question if A and B equal 1, then print 1. So we're just looking for basic binary on and off states. Else print, second line, print 0 and end if. Now because A and B both equal 1, i.e. they both have live signals or are both showing 1s, then this if statement will basically return the state of 1. So wait key and end. So we should now get the response 1 on the screen. Sorry, typed in then. You don't type in then there, you just type in the command. My bad. Thinking too much about the logic. So there we go. We now got a 1 response. Now, if I change any of these inputs to 0, we won't trigger a response anymore. We'll no longer get 1. We'll only get zeros passed back. So there we got a 0 there. And put a 0 here as well. Run the program, you'll still get a 0. And we'll try B is 1 as well. And there you get 0 again. So the best way of looking at it is 0 and 1 equals 0. 1 and 0 equal 0. 0 and 0 equal 0. And 1 and 1 equals 1. That's how we taught to learn it in electronics. So the only possible situation where this command will actually respond with 1 is when both inputs are live. Now you can add more than one input, so we can have a third option here, C as Boolean, and we'll set them all to 1. And we'll set another one in here, and C equals 1. So basically, because all 3 inputs are live, we should get the response of 1. So there we go, we've got a nice healthy 1 there. And if any of these inputs, any of them at all, are set to 0, or all of them are set to 0, then you will no longer get the response of 1, you will get the response of 0. So it will only trigger when all inputs are live, showing 1 being fed into the statement. You might ask how this is useful, but if you want to find out 2 key presses from the user, then you can use a command to get the state of the control key, and you can use a command to get the state of the A key. And if you combine those together with if control and A equal 1, then it will respond with 1, and you can trigger a series of events based on that keyboard command. But if you don't do it that way, then it won't work. So if you only press control or you only press A, then the statement won't be triggered. So it can be highly useful in that sort of situation. So we get rid of the second and there, and C, and we'll go back to our basics. So basically you can use more than one variable, more than one Boolean variable in the first part of the statement quite happily. The next operator we're going to look at is OR. So obviously this is another Boolean operator. And this time we're asking the question A or B. So if you put in the input 2 zeros, for example, as A and B, then this won't trigger it. You won't get a 1. So we'll run the program there, and we should get a 0 triggered. Okay. Now if we set both of them up as 1, so we got a live input on both of them, we get a response of 1 because one input is coming in, or the other input's coming in. Again, if we set A to 0 and B to 1, then it will trigger a 1 response again, because one of the inputs is sending a signal. And if you swap it around again, so this equals 0, so A equals 1, B equals 0, you'll still get a 1 triggered. So it's basically saying is A or B 1? If they are, then trigger the response of 1. So again, the only way not to trigger this statement is to put in 2 zeros, saying there's no inputs coming on in either. So as you can see, you got the response of 0. So again, the best way of looking at this would be 0 or 0 equals 0, and then it will be 1 or 1 equals 1, then 1 or 0 equals 1, then 0 or 1 equals 1. So the only state in which this command or this if statement cannot be triggered in is if both inputs are closed, they're not live, they're not sending 1s. So that's the OR statement. Now we're going to have a look at case statements. The biggest drawback to the if statements we've just been looking at is that there are only 2 choices, 2 absolutes. So it either is or it isn't, and sometimes you need a third, fourth, or even fifth state depending on the situation. For example, if a black box in a game had 4 effects, for instance, the first effect would kill the player instantly, the second effect would rob the player of half its life, the third effect would add half his life again onto his life, and the fourth effect would give him a weapons upgrade, then you basically have 4 states. So that box would naturally carry the ID 0, 1, 2 or 3. So keeping in line with that, I'm going to create a new integer my int as integer, and we're going to set my int to 0. Unfortunately, I can't really get into the full game coding right now, so I'll just create a very simple case situation. You do this by typing in select and then typing in the the name of the value you wish to apply to your case situation. So then you type in end select, which works in the same way as end if. Now the difference between end if is you can now create several cases. So case 0, end case. Any commands between case 0 and end case will be executed providing my int equals 0. Case 1, end case. Case 1, so if my int equals 1, then anything that appears between case 1 and end case will also be executed. You can carry on and do this indefinitely for case 2, end case. Again, if my int equals 2, then anything will be carried out from there. You can also set a default case. So case default, end case. So should the my int range fall out of 0, 1 or 2, case default will be put into effect. Of course, any instructions between those 2 points will be carried out. So to make it a little more interesting, we're not going to know which case is selected. So I'm going to replace the 0 with rnd, open bracket, 5. So now we could have a random number of 5 at any time generated when when the program first starts. It will generate a random number between 0 and 5. So if it's 0, 1 or 2, then those instructions will be executed. If it's 4 or 5, then case default will be executed. So we just need to give the case a little bit of code. So print case 0, we'll put print case 1, next we put print case 2, and finally print out of range. I tend to set the case default with an error message, so if it falls outside the range I expect, then I'll know it's done it, so the program won't carry on giving me errors, and it makes it easy to track things down. So now wait key and end. So basically I don't know which one's going to be triggered, so we're going to click on make exe and run. Out of range, so we've either had 4 or 5. If we run the program again, case 2 has been selected. So there we go. We now have a program that's able to take a piece of data from my int and then produce multiple results based on the data received. You should also note that anything can be put between these lines here apart from another case statement. So you can put an if statement, or you can put anything else in between. Another way of doing it is if you wish to have one case applied to multiple options, you can also put commas. So case 2, 3, 4, 5 and 6 will increase the range to 10, and this case will be case 1 and 7 and 10, and this one will be 0 and 9. So case 0, so basically should my int equal 0 or 9, then case 0 will be triggered. If it triggers 1, 7 or 10, then case 1 will be triggered. If case 2, 3, 4, 5 or 6 are triggered, then case 2 are triggered. If anything falls out of range, then case default will be triggered. So there we go, case 2 has been triggered. And just to confirm this actually is happening, we can also add another line here, print my int, so you get to see which value has actually been chosen. There we go, 10 equals case 1. As you can see, case 1 was selected because it's got 10 there.